The topic for Lesson 5.3 is indirect proof. You'll learn how to use indirect proof with algebra and indirect proof with geometry. How is indirect proof used in literature? In The Adventure of the Blanched Soldier, Sherlock Holmes describes his detective technique stating, "That process starts upon the supposition that, when you have eliminated all which is impossible, then whatever remains must be the truth." The method Sherlock Holmes uses is an example of indirect reasoning. The proofs you have written so far use direct reasoning, in which you start with a true hypothesis and prove that the conclusion is true. When using indirect reasoning, you assume that the conclusion is false, and then show that this assumption leads to a contradiction of the hypothesis or some other accepted fact, such as a definition, postulate, theorem, or corollary. Since all other steps in the proof are logically correct, the assumption has been proven false, so the original conclusion must be true. A proof of this type is called an indirect proof or proof by contradiction. The following steps summarize the process of an indirect proof. First, assume that the conclusion is false. Second, show that the assumption leads to a contradiction of the hypothesis or some other fact, such as a definition, postulate, theorem, or corollary. And third, point out that because the false conclusion leads to an incorrect statement, the original conclusion must be true. Most of the problems we're going to focus on are going to look like this, because that's all you can do on a standardized test, multiple choice. State the assumption you would make to start an indirect proof for the statement segment EF is not a perpendicular bisector. Our first step in an indirect proof is to assume the opposite, so segment EF is a perpendicular bisector. State the assumption you'd make to start an indirect proof for the statement 3x equals 4y plus 1. We would want to assume that 3x does not equal 4y plus 1. State the assumption you would make to start an indirect proof for the statement the measure of angle 1 is less than or equal to the measure of angle 2. Okay, if we want to start off with the measure of angle 1 is less than or equal to, the opposite of less than or equal to is greater than. So we switched the inequality around and got rid of the equals. So to start an indirect proof, we would say the measure of angle 1 is greater than the measure of angle 2. State the assumption you'd make to start an indirect proof for the statement if B is the midpoint of segment LH and the length of LH is 26, then BH is congruent to segment LB. The conclusion of the conditional statement they gave us was that BH is congruent to segment LB. The negation of the conclusion is segment BH is not congruent to segment LB. And just like we write an equals with a line through it, we could make a congruent symbol with a line through it, or write out the words. Okay, so here's the real McCoy. Write an indirect proof. If we are given that 1 over 2y plus 4 equals 20, they want us to prove that y does not equal negative 2. The first step in an indirect proof is always to assume the opposite of what we're trying to prove, so we're going to assume that y equals negative 2. So I'm going back to my given, and since we're assuming that y equals negative 2, I'm going to substitute negative 2 in for y. So I've got 1 over negative 4 plus 4. Okay, this is a contradiction on two different levels because division by 0 is undefined and it also does not equal 20. So our last step is always to say the assumption leads to a contradiction, therefore the assumption that y equals negative 2 must be false, which means that y does not equal negative 2 must be true. Marta signed up for 3 classes at a community college for a little under $156. There is an administration fee of $15, but the class costs varied. How can you show that at least one class cost less than $47? We know that Marta spent less than $156, and we want to prove that at least one of the classes costs less than $47. That is, if 3x plus 15 is less than 156, then x is less than 47. Since we want to prove that x is less than 47, we're going to assume that x is greater than 47. If we're doing greater than or equal to 47, we can just replace x with 47 and see if this works. Happens to be that when I evaluate, I get 156, which unfortunately means 156 is not, in fact, less than 156. So our third step, the assumption leads to a contradiction of a known fact. Therefore, the assumption that x is greater than or equal to 47 must be false. Thus, at least one of the classes must cost less than $47. And of course, we can use indirect proof with geometry. We're given triangle JKL with side lengths 5, 7, and 8 as shown. They want us to prove that measure of angle K is less than the measure of angle L. Once again, of course, our first step is to assume the opposite we're trying to prove. So the opposite of less than is greater than or equal to. So the measure of angle K is greater or equal to the measure of angle L. By angle-side-angle relationships, JL then would be greater than JK. It's the side opposite the larger side. So in this case, JL should be larger than JK. So 7 is greater than or equal to 8. This inequality is a false statement. Since the assumption leads to a contradiction, the assumption must be false. Therefore, the measure of angle K is in fact less than the measure of angle L. In summary, in an indirect proof, the conclusion is assumed to be false and a contradiction is reached.